Hello, my friend. Welcome to do after exam. About digital information quiz. The new topic we will start. New topic. Limitations of storing numbers. Will be some subtopic. Number limits, overflow, and round off. So let's start it. So first, we will put here our title. We'll say limitations of of storing numbers, storing why is like that, storing, yes, numbers, stop it, right. Storing in numbers. Okay, this one is okay. Now what I want to do, I will take this one as in the anyway, maybe I can take this one in ellipse like that. Yes, this one can be on it. Let's tag it, and okay, come here and just put this one in here. This one is okay now, and made it different color, maybe something like that. Okay, it's not a problem. And we have some subtopic, and I will tag this one, I will duplicate, and I will come here and I will say for it, maybe I can tag a little bit right, yes, like that. I will say for it number limits and overflow and round off. Okay, this one now here, and yes, I will do some line. Yep, this one it's a little bit right. What do you think? It's okay. Amazing. Now we will start to write. I told you limitation of storing numbers. Now we will process all the topics here. I mean number limits, overflow, and round off. Together we will see all of them. Okay. Now first we will write when. We will say when computer program store, little bit we write here paragraph. So we will represent what we have to, so what are we working on. So then I will go to integer representation, but before them I have to do it first. When computer program store, when computer program store, you can write also with me. I'm just notice you, just you have to do it. Program store numbers in variables, the computer needs to find, the computers needs to find a way to represent that number, a way to yes, represent that number, that number in computer memory, this is too much important. Yep, then say computers use different strategies, different strategies, 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 based on whether a number, based on whether, whether of number is an, um, 1 minute, a number, whether a number is an and then come down, integer or not. Okay, this is important place again. Due to limitations in computer memory, limitations in computer memory. Okay, programs sometimes programs sometimes encounter programs some programs let's come down sometimes encounter issues with important place here. Now we will add round of, okay, overflow, yes, or precision. This is really important place of numeric. Let's text it a little bit this place. Yep. Okay, this one is numeric. I think you've seen it. But okay, what I want to do here, now I will tag this one in uh, this color. Yes. And this one also same. But what I want to do same color for all of them. Where is it? Round off, right? It's have to be also like that. It's okay. I think you got what I said here. So it's all about that round off. So for round off, you can think like just you can think like 10 divided 3. It will give you not the bounding number. It will give lots of 3 that blah blah blah. So it will be like p, okay, p number. And really there is no solution, so real solution for that. It's all the time going, and precision is coming from there, and overflow is different also in this way. I mean, just think, you want to write there lots of things in, you don't know, you want to put in your memory lots of things, but you have 32 byte capability or 64 bit capability, but you want to put there 65 65 65 capability uh, information. Then your computer have some overflow problems. I mean, it can be closer 64 also, not maybe it will not overflow this capability. Maybe it will be close. Then the computers again, the modern computers will notice you, hey, stop, don't do it like that, or can be some message. Anyway, then numbers variables, just I forget here to put something more. I will put numeric variables. Okay, this one is like that. And let's come down. Yep, I will hide it. I will take again this here. And what I want to do, maybe I can go inside it, because all the things again will be in same place. Let's say integer representation, right? Come here, and it can be blue, right? Can do blue color. Yes, this color can be good. Or yeah, it's okay. Let's come right. But I don't want to go with this way. It's good with this kind of knowledge. Yes, now come down. We will start to speak about this integer representation. And let's do color black again. Okay, and, 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 okay. And Integer. Let's do it red. Okay, let's come here. An integer is only number. Okay, we will go together. Yes, go on here. Is only number that can be reading. Is only number that can be reading. That can be reading without a fractional component. Without a fractional. What happening? Fractional component. That's too much. Fractional component. Okay, let's do like what is it really? I don't understand. Just tag this till is do black. No, it's not that. What I want to do, it's not BBB, something like that, it's just black. Okay, it's only number that can reading without a fractional component, right? Now we will say the same term is used in the same term. The same term is used both in both programming and in math. Programming and math. Okay. So hopefully, hopefully it's familiar to you. It's familiar. It's familiar to you. I will explain what I'm saying you. Now I will say all of these numbers are integers. And come here and say 120 and 10, 0, minus 20, something like that. How can a how can a programming language represent those integers in computer memory? Those integers, those integers in computer memory. Will now we will write all computers. Computers represent all data with bits. All data with bits. Okay. So we can know that ultimately each of these numbers is a each of this each of this those numbers is a sequence of sequence of zeros and ones. Okay, let's come down and say to start Simple. Let's imagine a computer. Start simple. Let's imagine a computer. Let's imagine a computer. Middle down. Let's imagine a computer that uses only 4 bits. That uses only 4 bits to represent integers. To represent integers. Okay. Represent integers. To represent integers, it can use the first bit. It can use the first bit. This is the important place. Again, listen carefully. Is the first bit to represent the sign. To represent the sign. What I'm saying here, sign operator. I mean, the sign of the integer. Sign of the integer. Okay. Positive or negative. Positive or negative. Positive or negative. Negative. And the other 3 bits. And the other 3 bits. So I mean here it can be something like that. The operator. So like that. The operator can be 1 bit can be that operator, then other bits can be some numbers, okay, like 3. So again 0 1 1, something like that. Okay, it's not important. Anyway, I will show you all. And then 3 bits for the absolute value. 3 bits for the absolute value. For the absolute value. Okay. So that system, the number one would be represented like this. Would be represented like this. And yes, come down. Okay. Now I want to show you that here. This one is I'm saying here. So anyway, I will come here. I can show you my example in here. The first one will be 0, 1 2 3 4 5 6 6 times. I can put 1 2 3 4 5 6. Yes. Yep. Now I will say here, maybe I can take little here. Yep. And say this is plus and minus. Operator here. Then we have, that 4. So what is this for? Power of 2. This one is power of 1, right? And this one is power of 0. So anyway, all kind of things. Anyway, now what we want to do, I will put also down of it. Maybe I can tag little down to represent this subject. Like I can say this is sign. Yep. I can tag this one is there. Okay, this one will be sign, and this one will be 2 power of 2. This one will be 2 power of 1, and this one will be 0 power of 2. Okay, let's come here and put there with the 5, maybe 6. Yep, put there 2. We need also 1, I think, and we need also 0. How we can how we can do that? Yep, I think we can solve now these things. Okay, it will be here and this will be there. Okay, now you know what I did here. This is that. This place for sign. This place power of 2, 2 power of 2, 1 power of 2, and 0 power of 2. And we can represent 4 bits like that. So what we said here, imagine a computer that uses only 4 bits to represent integers. It can use the first bit to represent the sign of the integer, positive or negative, and the other kind of knowledge. So anyway, I think you got it. What I said here is the first place. Now I will come down and we will write again things here for understand better. Let's say down of it. Yes, come down and say right. The 0 in the sign is in the sign. It represents positive number. Yes, this is true. If there is 1, this is odd number. If there is 0, this is even number, right? So this is positive and 1 is negative. You have to think like that. Number and the 1 and and the 1 is the and the 1 in the right rightmost. I mean, that's in there. Just come down. Okay, rightmost. I mean, right side. Rightmost bit negative. Bit represents the again this information here, but it will take all. Oh, it will make me tired, but it's okay. 2 power, so 0 power of 2, and it will be 1, you know already. Place of the volume. So you know the 0 is already, it's representing 1 times 1 is 1, but 0 power of 2 it will be 1 or 0. Okay, we know that. So okay, now I will put the 0 there. Yep, I will come here and just I need 6 here to represent the situation. I will say 0. Just I will put here this 0 again. And it can stay there. I think you can understand the situation here. So what we said here, the 0 in the sign, it represents a positive number, and the 1 in the one on the rightmost bit represent the 0 power of 2. It's already 1 place of the value. I mean, okay. And just come down. What is the largest number? What is what's the largest number in this system? Uh, this system could represent. This system could represent let's let's fill all the volume. Let's fill all the value. Let's fill all the value. Value. Let's fill all the value bits with 1 and C. I'm down. We will do together again. Same thing. I will take this one again from here. Okay. This one, and I will come down and I will just paste it here. Just I want to go right side. Okay, there is nothing changing, so just we will put 1 for this ones. This one is okay, but I think we forget the power of these numbers. But I think we can do it with which way. I think these numbers we can. Oh, what happened? Anyway, just come again here. Yep, come down here. Let's say duplicate it and take it here. Okay, now I will come again here. Sorry for it, I don't understand what happened here, but it's okay. Now I solve problems again. Okay, now try to understand this sign here, positive or negative. We can use this place here for the sign, and the other ones will be 1 1 1, so it will be, what will be it? So just 1 time 1 is 1, 2 time 1 is 2, 4 time is 1, and it will be 7. Already we know that. So what we can say for it? We can say, so anyway, I don't need to do anything there. We can say that's that's the that's the positive number 7, positive number 7 signs, since and what I want to do here, I will tag this again. I have to tag this one from here. Yep. Yes, this one again from here. And really just I need to put there some plus between them. Okay. Just do something like that. And do also here. Same thing. This one is very bad, really. Okay. Just come in here. Do these things here. And it's okay. I think it's okay. Then the last one, it will be 7. I mean, we can show that with this knowledge. We can say 4 plus 2 plus 1. And 1, it's equals 7. So now we will say, I think you got what I said here. The 0 in the sign bit represents a positive number, and the 1 in the rightmost bit represents the 0 power of 2. It's 1 place of the value. You know that already. I mean, so the last value is we just represent that with the 0. It's just like plus or minus. We just represent it like that. We have 7 bit there. So we have 7, decimal number 7 we can represent here. The other one, it will be 8, but it's not 8, it's just sign operator, okay? Sign marker. So let's come down and we will say here, check your your understanding. Okay, check your understanding. And really we can do it with which color? With little bit black, maybe something like that, just for showed you. And just come down, this will be some question here, but before that I have to do color black. And let's say consider a computer that uses consider that a computer that a consider a computer uses oh, computer that uses 6 bits to represent integers, say this, and one bit here only for the sign, for the sign for the sign, yes, and 5 bits, and 5 bits here for the actual number. That's good. What's the what's the largest positive integer? What's the largest positive integers? Positive integer, maybe, right? Integer, it can represent. That's good. Now, okay, what we have to do here, I will tag, no, yes, this one, rectangle here, I will put in this place. This will be answer. Okay, let's come here and think. We have 6 bits. Okay, let's do together. Okay, we will do together. It will really help you. It will give you some benefits. Don't torture you too much. Just wait me. I will help you to solve this problem. Just 6 bits. 6 bits. We have to think 6 power of 2. What will be that? I think this will be 32, right? This is 32. Now, what do you think? What we can do for that? The first number, if we think 6 bits, so we have to think we have 6 power of 2. 6 power of 2 will be like 64. We know that, right? The 64, we are not looking for 64 because 64 will be our uh, sign. So our sign here. And the other ones will be our actual numbers. So what I am saying here, now we will understand better, okay? Now I'm saying the first one is sign, and the other one will be actual numbers. Can be 1, 1, 1, 1, 1. So we have 6 bits, 1, 2, 3, 4, 5, 6. And the left one, the leftmost, you can think like that, left one, it will be sign. So, okay, we will represent it like that. 1 bit for the sign and 5 bits for the actual number. So, okay, this one is sign and the 5 bits for the actual number. Okay, now we know this knowledge. Okay, if you want, I can put here for show you to understand. The first one will be 0 because this is sign. It have to be positive to show it situation. Okay, if you put there 1, it will be 64. So we just have to think like this is sign. Okay, like with the 0. Okay, let's look at for other ones. What we have to do here. Uh, Now you have to think a little bit good. 4 and 5 bytes for the actual number. Let's put 1, 2, 3, 4, 5. 5 for actual numbers. Okay. This one, it will be 16. Other one will be 8. It will be 24. The other one will be 4. It will be 28. The other one will be 2. It will be 30. The other one will be 1. It's 31. What do you think? This is 31 or what? What's that? Just think about that. What do you think? 1 times 1, 1. 2 times 1, 2. It's 3. 4 times 1 is 7. Now, total. And 8 times 1 is 15. 16 times. Yeah? 16 times. So 16 plus 15. 31. Yes? What is the actual number here? What do you think? So just you have to think about that, right? This is really good question here. Yes, what do you think? This one is 31, okay? Because I told you this 16 plus and 8 plus 4 plus 2 plus 1, it will be 31. Our answer is 31. It can stay here for help you, I think, so if you want. But anyway, just maybe I can delete this one. Okay, just I will put it here. It is just some explaining. Okay, maybe I don't want to mix your brain, so I just want to put here 31. So it's okay. It can stay here. Now we will start overflow. Yes. Yes, friends, now we will start overflow, our other topic. Yeah, maybe I can go up and I can tag this one from here. Same color. Yep. Let's come down. Yep. Okay. But anyway, we lost about color. But what will happen? Oh, it's amazing. Okay, let's do it like that. Anyway, then come this place. Maybe it's good. Okay, now let's write. We will write lots of together. So really, this will be long way to do things. What happened here? I think I have to copy this. Really, I will delete this one and just I will start here and we will go on all the way like that. But then I will say this will be black and our colors will be black. Exactly. Okay, let's come down. Say for it overflow. Overflow. Yes. Now come down and start right here. What? I'll view again. I have to do black. This one. Right. What? Yep. Would happen if you run? What would happen? No, not would. What would happen if we run a program? If we run a program, like this on the forbit, like this on the forbit, not forbit, it's forbit. Computer, where the largest positive integer, where the largest positive integer integer is 7. 7. Integer is 7. But the largest positive integer is 7. Okay, let's do something here. We can say var. This var meaning variable we are using in JavaScript programming language. So it's in Python we don't do anything like that, but in JavaScript using var meaning like variable. You just representing their float number, integer or string variable. Okay, for that. So anyway, what I want to do here, and I have to say var x, this is our variable, this one is x, equals, you will learn all, don't worry about that. Okay, for now it's, you don't need to understand this step. This is 7. Okay, this is some semicolon, it's, we are putting end of this, so it's arbitrary. Maybe if we want, we don't need it. Then var y, it's variable y, it's equals x plus 1. Let's put it there. Now x, what can be here? So just think about that. Now what do you think about that? Var. Now var x, we know already this is 7, right? We represent it with the 7. So we put our number 7 in our variable of x. Now x plus 1, it will be 8, but now you have to think, what about, now 3 power of 2. Now you will think like what? Like that. Now if the thing come overflow of the numbers, then we have some problem. Anyway, I will write, you will see. I will say the number, yes, the right. The computer can store, the computer can store the variable x, x just fine. Yes, really just fine, because 7 is already there. Okay, fine. But is but y is greater than than the than the largest integer. It can represent with so with the what, with the 4 bits. 4 bits. 4 bits can be what do you think? 0 power of 2, 1 power of 2, 2 power of 2, 3 power of 2. So you know already what is that, right? 4 bits. Now anyway, in a case, I don't want to give you some hint, because we have to go through our experiments, our practice, and our things. In a case like this, in a case like this, the computer may report. The computer may report what report? The situation report, an overflow error, an overflow error. Why overflow error? It's all about x plus 1, because 7 is okay, but x plus 1, so 7 plus 1 is problem, because in 3 power of 2 just we can represent there 7, so you have to subtract 1, for situation. So 4 plus 2 plus 1 is 7 already, right? Anyway, our display or display or display a message like a message like number is too large. Number is too large. Yeah, computer can do it. Yes, and put that. I think that is okay. Good. Okay, it may also truncate truncate the number the number capping all results to 7. So I mean capping, right? Yes, capping all results. I don't know these words too much. Results. I think results. All results to 7. To 7. Yes. Or wrap the wrap the wrap the number around wrap the number around that 8 becomes 1, so that 8 becomes 1. I think you get what I said here. This is the important point. Anyway, going on, we're saying here we don't want to end up we don't want to end up we don't want to end up in any of those situations. So it's important it's important we know the limitations. So it is the important place to understand situation, friends. Now what I said before start this place, I told you we have limitation problems. So I told you in the modern computer we have 64-bit. Before the modern computer we have 32-bit, then it's going all the way like that. So our technology, when we are going to improve our technology, the system is changing like that. So now we have 64 bits for represent the things, and we have we just uh, expanding integer numbers range. I mean, we just arrange all the numbers again. So in the bits, we just made largest range of the integers for represent with the bits. I mean, anyway, I think this is don't not don't or something like that. What is that? Don't. Yes. Limitations and okay. We know limitations of our language language and environment when reading programs. This one is good. Now we will say check your understanding to understand situation, maybe. So check your understanding. Okay, let's come here. Let's do it and do some color in this way. Yes, maybe something like that with point shot. Now say on a computer, yes, do black like on a computer, on a computer, right, which uses 6 bits, which uses 6 bits to represent integers, with 1 bit to represent, with 1 bit to rep, uh, with small place, 1 bit to represent, the sign, I mean, right, the sign, okay, which which of these operations, which is this operation, which of these operations result in overflow? This is amazing question. Now just check your information, what you learned here. Choose one answer here. Okay, one here. Maybe I can take little down because things is very close. Okay, let's look at the answer. So our things G and D, right. So what we can do, we can say, we can do something like that. Okay, the A will be 15 plus 15. The B, what will be B? B will be 24 plus 6. Okay, the other one is just 30 plus 1. The last one is 3 plus 29. Okay, let's do together. The first one, look at the first one. Now the first one, I will do this marker, I mean greater marker, to show the situation. Now what I want to do here, friend, I want to do something like, maybe I can take, no, maybe it can stay like that. Okay, let's say this is 6 power of 2. Yes. Okay, say this one is, maybe we can do 6, and we can do 5. Okay, let's say this one here, 6 power of 2. Okay, let's come back here. 6 power of 2, it's 1 bit for sign. I mean, we will use 1 bit for sign. It will be for sign, 1 bit, right? Sign, I mean, 1. Yes. For sign, now we have now 5 power of 2, because one piece we use for the sign. Now we are looking for 5 power of 2. Have you counted? What do you think? What is this? Okay, we can solve together this situation. Let's say this one is, we know already, this is 31. Why? 0 power of 2, it's 1, right? 1 power of 2, it's 2, and it's all the way going for 5, it will be 31. Okay, now this one is 31. and 15 plus 15 is 30. We have to say minus 30. This equals 1. So, I mean, there is no overflow. Still, we have one decimal number to represent things, or still we have a place. Let's look at other one. Yes, look at this one. Yep, this one will be same again. Just I will do something like that. It's just representing same thing. And till here, maybe do this for here and stay for here. And let's do it two and take this one there. Yes, and say this equals, again we will do same operation. Is it will be 31 minus, what will be this, 24 plus 6 will be 30 again. It's again 1, and there is no situation like that, so it is the same information again here. Okay, it will be the same thing. Okay, let's come again down. Let's again we have same situation, we know that, right? Stack it a little bit right. Yes, and do it here, and let's do it here. Okay, now again this one here, and our information there. Just tag 5 power of 2 exponentation and just say it's equals 31. Yep, and 31 minus 31, it's 0. So still we don't have problem, because this is we fitted our information here. So really there is no problem. There is no overflow. Let's come here. Have you see solution? And look at this one here. Yes. This one, it will give us the solution. Just come here and tag from there. Just put there and go on this way. 31 minus, because we know, right? 5 power of 2, it's 31. But here, 29 plus 3, it's 32. But if we count 5 power of 2, really it is not 32. Normally we know 32, but you have to think always minus 1. Why the situation like that? The 0 power of 2, it's always 1. Okay? 1. Then 5 power of 2, it will be 4. So 4 power of 2, it will be 16. Then 16 plus 8 plus 4 plus, so 8 plus 4 plus 2 plus, and we know 0 power of 2 is 0. It will give us 31. Okay, all the time it will be 32, and it is really problem. It is really problem. It's minus 1. So we can say there is overflow. So computer will be crazy, because computer cannot represent this, and this problem. Then computer really will stop. Computer will not work. It's really not good situation, because just think, you can think like what, we have 64-bit computer. Modern computer is not possible for now, but just you can imagine like that. Okay, because we are speaking arbitrary here. So just think, you just put there, you store there lots of information greater than 64-bit. So then you can think comparing, we are with the decimal number, it will be too much than 64-bit, then computer will be crazy. Computer cannot store it, and really it will give you some error. It will show you some error for show the situation, or hey, stop, don't do it, or computer cannot work, really, believe me. So what we have to say here, we solve problems now here, and I will just what I want to do, I just do green again. The, this one is really, we here we have problem. I mean, this one is overflow, this one is problem. The other ones is really true. So computer can store 30, 31. It's really not problem, but 32 is too much. Then 31, it will be different. So let's write information again here. Fortunately, yes, fortunately, most modern computers use most modern computers use I told you 64-bit architectures which can store which can let's come down, store incredibly large integers, incredibly large integers. This is true. In JavaScript, the I think I can do this script bigger. Yes, in JavaScript, the largest safe integers is the largest safe safe integers safe integer is, yes, let's write this number 900, yeah, maybe I guess 007, then 199, then 2, like that, and 740, then 992. Yes, yep, computer can store it really lots of, so this is big decimal number. Equivalent, I mean, equivalent, the situation equals, I mean, equivalent to 2. Let's see what I'm saying. Say 6 for it. Anyway, where is our I think I forget it. Right, so let's say this is 53 power of 2. Wow, this is really amazing, right? Yeah, it will be here. Yeah, then minus 1, already there. So beyond that, and we are, and we're, and we are, and we are in the danger zone. Danger zone. Really, we are in danger zone. This is crazy situation. Yes, let's calm down. Now, what I want to do, I want to show you something, okay? Now, let's come with me. We will go in one place. You will understand me better in this place. Now, let's come in Visual Studio Code. In the future, we will use this array, okay? For now, don't worry. Just we will do something together. Don't worry for the situation. First, I will come here. But anyway, maybe, yeah, okay. We can create here one file, HTML file, and we can work on HTML file with JavaScript because I want to show the example with JavaScript, okay? Anyway, I will say example save number dot html. Let's come here. Now we say HTML5. What's happened? 5. Yes, this one is here already. Okay. Now let's come here and say script. Okay, this one for JavaScript, also for CSS we have different, but really just what I want to tell you, please don't think about this place for now. We will speak about it later too much. So I will really show you how to programming, how to write codes there, and really it's all okay. That's right here, console.log and say number plus max save integer. What it's doing, it is showing us the the I mean the last integer number. We can work with it, so we can store last maximum save integer. I mean this one. Okay, what we have to do now I will port internet, I mean one website. So really I will speak about all. I will say go to live, and it's okay, server started at some point. Okay, let's come here, then inspect. Now we will see in the in console. Where is our console? Here. Yes, have you seen this number? This number is same what I showed you in this place, right? Look at this one. This one is the same with this number. So what we write in the program is the same. Okay, anyway, let's look at, I will show you some other thing also here. Maybe we can write also, maybe computer can be crazy, but I will try. Then we can say number and max integers and say 1. Let's save it. You see, normally it's not possible, but it's just we doing some fun. Okay. Anyway, let's try the other one with one more. Let's do 2. Okay, let's come back here. Let's have you see the situation going same. Let's do something again. I'm saying you this is some fun. Okay, let's come here, say console.log, and we can say what we can say. Maybe really we can go way higher in the danger zone. I mean, we can say math, right? And math, and we can say pow. It's this. I mean, explanation. We are using this one, and just we can say to 1023 power of 2. What do you think? Say this one. Amazing number, right? Wow, have you seen this number? This number is really crazy number. I never see in my life. I never seen it in my life. Let's say more 4 maybe. So just don't think about this place, please and please. I will teach you all of this, but still we are not in this situation. We are not in programming or programming languages. Still you need 4 5 topics. When you finish with computer science, uh, I mean all things, then you have to go with me about programming languages, but don't think about it too much. Just we are speaking about now overflow our prob- our flow problems now, but pretty soon we are at infinity. Let's say, or what do you think? Will be infinity. Look at that. This one is infinity. Okay. The last situation is that. Also, what I want to show you last thing, I will open it here. Maybe I can say example pi. In Python, we have also same situation like we can do maybe we can say max safe, and we can say mm, math. I think math is possible. No, I think we have to import it. Import math, maybe. But I think we have to import Python or something like that. Get intelligence debugging and more. I think we have to install it anyway. I don't want to do it now, so later we can do something together, but in don't save it. So you saw here, okay, all my information. Okay, let's don't speak about too much about programming. Let's go to back our place in this area. I will close this place. Read it's too much. Now we will speak about other things. I mean, so I will close this place and let's come down and say here. Maybe I don't want to say something here. I just want to go this place and really come left little and right, but not yes, maybe okay, just tag this one and maybe copy that this one and come here. Really we will do something here together. Okay, let's come left with this information. So now what we have to say, this is our floating point representation. Now we will speak about here. Okay. Yes, my friends, let's start this place. Now we have to explain the situation. Also, floating point representation is too much important if you want to understand concept of binary system, how to represent float numbers, or just think like 1 divided 3, how to computers divided the how to computers represented, or this with the 0 1 bits, right? Maybe you were thinking about that, right? So I mean, just thought of it, consider it. We have 1.25. This is the there's irrational, so there is some rational number, right? So 1 divided 3, or really we have lots of number. 1.5, it's like float number, and how computer can represent this? So Okay, we will see all together. Okay, this is not power of 2 or power of 3 or power of, just think, 8.5, or really just think, 64.75. Computer cannot represent it with the 6 power of 2, right? Because this is not 6 power of 2, so it's different. We have to do some different things. Okay, I told you, for some integer numbers we have to solve also something. So anyway, I will start now. I will say, anyway, here's what I want to do. I will do black. Let's come here. When, so not the when, it's we've seen there are limitations to storing integers, to storing integers in a computer. Numbers, let's come down. Really, I don't want to overflow it. Let's, so numbers, yes, that aren't integers, right? Numbers that aren't integers, of course, sometimes, like fractions, I mean that, okay? We can represent it, fractions. It's an important point, but I will explain the whole situation. And irrational, irrational, irrational numbers are number are even trickier to represent in computer memory. Right. So it's okay. I'll do this one. Let's come down and say, consider considers numbers like this. Yep, 115 or 1.234. It really cannot, so it can be in computer. You all the time writing these numbers in math. Maybe you're doing some project and always you using this number, right? And also come down, so come there again and say 9.0000, no, 999, 99999, something like that. Or what? Or the famously, right? Or the, not famously, yes, famously never ending, never ending, ending. I don't have, so I have to find out, but anyway, I will do it. This one. This is P number, I mean. Okay, this is P, okay? You know what is it? And really, I can do this one is here. And what I want to do, I want to add here, I want to say, what do you think about that? I think this one is not good, really. Yes. Maybe I can type from some website. I don't want to do it this way because it's not looking too much good. It seems bad. I can say p number is equals to something like that, but it's okay. P number, just say something like that, and I can, what is it? I just want to tag, yes, this one here, right, and just add it there. So, I mean here, yes, and say for here it's just the number, it's no ending there. Where is our information? Yes, never ending p. Now we will say also, anyway, I will go on computer languages typically typically use this is the information good here, floating point representation. Let's take this one in red marker, so in red color, creative. This is the good information for understand. And let's go to do it black. Yes, and goes as, let's do this black. Let's say black. Let's say true black. Okay. Floating point representation for oh, what happened? No, really don't do it. Black. I don't want to delete it. For non, let's come down. For non-integer. For non-integers, not integer, integers, and sometimes integers too. Really, sometimes integers too. It's similar to scientific notation. Scientific, let's come down. Notation. So representation. A representation. You may. What is it? Representation. Only that. Yes. You may know from other studies. Okay, let's say in floating point representation, let's do it, floating point representation. A number is multiplied by a base that's raised to an exponent, right? So what I'm saying here, let's come down. I will give you some example. Nice example. It will be 300 So it will be 3 times 10, so 2 power of 10. So it is binary system, like in decimal system. What we are doing for represent 100 or for represent uh, 1,000, we saying 3 power of 10, it's 1,000. We just don't want to write there 1000 and something like that. Or for 1 million, or just think 100,000, how you can represent it. Just you have to say 5 power of 10. It's true, maybe. Yeah, I think 5 power of 10, it will be thousands. So 5 power of 10 will be 100,000, like this. But we don't want to write all of this zero. Just we have to represent it this way. Anyway, I will come here and I will say for this place, just take it 6, right? Do it. Come down and say this is the 2. Let's take this one and come here. Yes, 3 times 2 power of 10, it is already 300. We know that, right? And just what I want to do, I want to do something here. Maybe, yes, I can say this one, yeah, something like that. I can say this one is exponent, right? Exponent. Let's look at me what I'm doing. Yes, I am professional man. Yes, do it. Yeah, let's say this one is exponent, and the other one we can duplicate it, and let's come down. So maybe we can do this one is like what, like, let's say this is, no, this is not exponent, anything like that. Let's say this base. So 10 is base, right? 2 is exponent. So let's go on again. I think you got what I said here. And since computers use binary system instead, the binary system instead of the decimal system. So the base for floating point numbers, the base of floating point numbers, the base of for base for of not